Hello students, welcome to Breedmark Academy. Myself LS Nanda. Now in our previous year question series of JEE Main and JEE Advanced, this is the today's question. This question involves the concepts of modulus function, differentiability and definite integration. It says let f of x equal to 2 plus mod of x minus mod of x minus 1 plus mod of x plus 1 where x belongs to capital R. Consider two statements S1 and S2. S1 says f dash minus 3 by 2 plus f dash minus half plus f dash half plus f dash 3 by 2 equal to 2. And S2 says integral minus 2 to 2 f of x dx is equal to 12. Now we have to find out which of these statements are correct. Now students, to solve this problem, we will make f of x free from modulus sign. And for this purpose, we will put every expression inside the modulus sign equal to 0 to get those values of x at which f of x changes its definition. Now when we do this, we get three values of x. One is x equal to minus 1, another is x equal to 0, and the last one is x equal to 1. Now we will locate these points on real number line. And now you can clearly see these 3 points divide the entire real number line into 4 regions. The first region is when x is less than minus 1. The second region is when x is greater than or equal to minus 1 but less than 0. The third region is when x is greater than or equal to 0 but less than 1. And the fourth one is when x is greater than or equal to 1. Now students, when we consider the first case, then in the first case, since x is less than minus 1, so the value of f of x becomes 2 plus. Now since x is negative, so mod of x becomes minus x. Since x is smaller than minus 1, so obviously it is smaller than 1. So mod of x minus 1 will become 1 minus x. So minus of mod of x minus 1 becomes plus x minus 1. And now students, since x is less than minus 1, so x plus 1 is negative. So mod of x plus 1 becomes minus x minus 1. Now just simplify. And now you get minus x as the final value. So f of x is equal to minus x when x is less than minus 1. Now we move to the second case. Now students, we discuss the second case. In the second case, x is greater than or equal to minus 1 but less than 0. And now the value of f of x becomes equal to 2 minus x. Now this time x is smaller than 1. So the value of mod of x minus 1 will be 1 minus x. So minus mod of x minus 1 will become plus x minus 1, right? And since this time x is greater than or equal to minus 1, so x plus 1 is greater than or equal to 0. So the value of mod of x plus 1 will become just x plus 1. And now just simplify it. So you get the value of f of x equal to x plus 2. Now we move to the third case. And in the third case, x is greater than or equal to 0 but less than 1. Now the value of f of x becomes equal to, this time x is greater than or equal to 0. So mod of x becomes x. And since x is smaller than 1, so mod of x minus 1 is again 1 minus x. So minus mod of x minus 1 will become x minus 1. And mod of x plus 1 is just x plus 1. So now this time we get the value of f of x equal to 3x plus 2. And now we discuss the last case when x is greater than or equal to 1. And now all the expressions inside the modulus signs are positive. So the value of f of x becomes 2 plus x minus x minus 1 plus x plus 1. And now this becomes 2 plus x minus x plus 1 plus x plus 1. And this comes out to be x plus 4. Right? Now students, we move further and check out the statements. Now students, the function f of x becomes equal to minus x when x is smaller than minus 1. It is equal to x plus 2 when x is greater than or equal to minus 1 but less than 0. It is 3x plus 2 when x is greater than or equal to 0 but less than 1. And finally, it is x plus 4 when x is greater than or equal to 1. Now students, from here we can easily find the function f dash x. Now f dash x becomes minus 1 when x is smaller than minus 1. It becomes 1 when x is greater than or equal to minus 1 but less than 0. It is equal to 3 when x is greater than or equal to 0 but less than 1. And it is again 1 when x is greater than or equal to 1. Now students, in the statement S1, we have to find the value of f dash minus 3 by 2 plus f dash minus 1 by 2 plus f dash 1 by 2 plus f dash 3 by 2. Now since minus 3 by 2 lies in the first region, that is where x is smaller than minus 1. So the value of f dash minus 3 by 2 is going to be minus 1. And similarly, you can find all other values. Now minus 1 upon 2 lies in the second region. So the value of f dash minus 1 upon 2 is going to be 1. The value of f dash 1 upon 2 is 3. And the value of f dash 3 by 2 is 1. So the final answer comes as 4. So that means statement S1 is wrong. Now students, we move to the statement S2. Now students, in the statement S2, we have to evaluate the integral minus 2 to 2 f of x dx. And since we know that the function f of x is changing its definition at 3 values of x, that is at x equal to minus 1, at x equal to 0 and at x equal to 1. So accordingly, we will break this integral into 4 parts. The first integral is minus 2 to minus 1 f of x dx plus integral minus 1 to 0 f of x dx plus integral 0 to 1 f of x dx, and lastly from 1 to 2 f of x dx. So that means you have to divide or break this integral at 3 values of x, that is minus 1, 0 and 1. Now students, we will evaluate these integrals. From minus 2 to minus 1, the value of f of x is minus x. So just put the values of f of x in all these specified intervals. From minus 1 to 0, f of x is x plus 2. From 0 to 1, it is 3x plus 2. And from 1 to 2, it is x plus 4. Now just evaluate them. It becomes minus x square by 2. And the limits are from minus 2 to minus 1. It is x square by 2 plus 2x. Limits are from minus 1 to 0. It is 3x square by 2 plus 2x. Limits are from 0 to 1. and it is x square upon 2 plus 4x. Limits are from 1 to 2. Now just find their values. It becomes minus common outside. So this becomes 1 upon 2 minus 4 upon 2, which is 2. Now this becomes 0 minus, inside the bracket we will get 1 upon 2 minus 2. This becomes 3 by 2 plus 2 minus 0, and this becomes 2 plus 8 minus 1 upon 2 minus 4. Now students, we do the calculations and get the final answer. Now students, the value of the integral becomes 3 by 2 plus 3 by 2 plus 7 by 2 plus 11 by 2, and this comes out to be 3 plus 9, which is 12. So that means statement S2 is correct. So hence option D is the correct option. Now students, next question I will be posting in tomorrow's video. Till then, goodbye. Keep watching my videos and enhance your knowledge of mathematics. Thanks.